Hi everyone, this is Raju from Smart AI Technologies. Welcome back. Today we will going to discuss how to convert from speech to text. Before moving further, first we will see in the end what we will get in our project. So in the end of the work, we're going to are able to detect what is there in that voice, like wave files or voice files. Okay, here the target, that means the original voice files was containing. The committee does not seem to have yet understood new gate could be the only properly replaced. This is the content in that voice file. Okay, now what does our model detect? The committee does not seem to have yet understood that new gate could be only and probably replaced. The here you can see, here it made some error, that is instead of sir it gave it as ser. Other than that there are no error in this. Okay, and here also still no sentence of death was carried out of offense and 1832. Okay, like this. These are all target, means these are all the original content of the voice file that I am feeding to my model, and it is predicting properly without much error. That is our we try to measure it using WER, word error rate. The word error rate in our case is 15% or like that. It means very less. If I have 100 words, only the possibly like 15, maximum 15 words will be wrong. But here you can see out of 15 words are like that, there is single word or no word error is coming. Okay, and here I am using a deep learning model which is just like deep speech to. If you work with the speech to text technology, you'll be knowing that what is deep speech to. Just like deep speech to, I built our own models, so we are using the own built model to train. Here you can see. Okay, we are calling it as a deep speech 2 because deep speech 2 is one of the famous model which is already available and which is giving actually a very good results. Okay, I'm calling that as deep speech 2 itself. Okay, we are building that model, we are training that model, we are not using any pre-built models. Okay, then also we are getting very good results. Like you may heard of wave to vec speech, deep speech 2, and there are some technology like sequence to sequence of NVIDIA. There are so many already pre-built technologies where you can use them and you get the result. But here we are building it from base. We are going it from getting the data set to training the model and testing the model. So if you are a research student, if you are final year student, or if you are enthusiastic in machine learning or like that, it will be a very good topic. Please watch it completely. I think it will be worth. Okay, you'll be getting good knowledge from this. Yeah, that's fine. This will be the result. First we will start to discuss about it. Okay, here I'm using website called webwhiteboard.com to teach you. Okay, just like a whiteboard. Now what is this speech to text mean? Okay, this is a technology actually. Okay, in this technology what will happen, here we are using deep learning. Okay, here we are using deep learning. Here what will happen, our input will be voice. Okay, and our deep learning model will take that voice and it will extract and give the text out of it. Okay, if you want to define, you can say like a technology which can transcribe voice to text. We call it as a text to speech to text application. Okay, that's fine. Now why we should need it, what is the importance or what is the requirement to have it? Okay, then we need to know what are its pros and cons. When we come to pro, we need to know some application, then we'll understand its pro. For example, here uh, if you are a teacher. Okay, if you are a teacher, or if you are an uh, you are a company person. Okay, you need to submit your files or your report. Like if you want to type it, it will be boring task, or it will take around 1 to 2 hours to type everything. What if you can just speak whatever you know, and that will be directly converted to text. It will take 5 to 10 minutes. Is that fine? It means this is the time saving stuff. Okay, then second application I will give you. Second application is like search engines are using it. Search engines, for example Google. Okay, in Google you can search using your voice. What is the profit, or the what is the benefit there? If you don't know how to write English or how to type English and that stuff, you can directly speak whatever you want and get the result. Okay, if you have babies in your homes, you will be knowing that they will just speak using Google Speak, and they will search in Google or YouTube. Okay, you can do this. This will save time, and these are all the benefits. Okay, uh, and also the third one is e-commerce sites. E-commerce sites also same. They also just act as an search engine like stuff. Okay, they will take input from your voice and they will convert into text, and then they will push it to get the database information about whatever the stuff you are searching for. So when you see this application, what are the pros that you are getting into your mind is, one is it will save time. Okay, uh, it will it will save money. Okay, and the third step is it will be very helpful, and it will increase the productivity of company if a company is using it. Then comes cons. Okay, the problem here is there is no model which is 100% accurate. Okay, you can't make any model 100% accurate. There will be some losses. In that case, you need to go and edit uh, already the text you got from the speech. Okay, there you need to waste a bit time in editing it. These are all the cons. Okay, now we understood like what are its application, what's pros and what are its cons and all those things. Now how we gonna implement it now? Okay, how we gonna implement this and how we gonna get the result in our case? So here what we'll do initially is, we have a data set. The data set is structured like that. It has two folders. One is wave files and another one is CSV file. Okay, I will show that data set and from where you will get the data. One is CSV file, another one is folder which contains wave files, that is voice recorded files. This is about 2 GB or like that. Where this data set is available, you can see here. Okay, you can directly download it from here. Okay, Keith-Eto LJ Swiss dataset, or you can download it from Kaggle itself. Okay, you can download it from here also. The dataset is available from both the sides, and you can see the structure of the folder. Okay, under waves, all the wave files are there. Okay, all the voice files are there. Under meta.csv, for each voice file, LJ0001 like this. Okay, for each voice file or wave, okay, there will be its text available. Okay, it means both input and output is available. Input is our voice file, output is the content of that voice file. Okay, like that it is available. So we will take that, we will pre-process that data, both the data, voice data pre-processing and also CSV data pre-processing. We will do the pre-processing. We will convert them into tensors. Okay, in the end, and we will batch them and we will feed them to a deep learning model. Okay, we will feed them to deep learning model. Once this deep learning model learn, this deep learning model, let us say deep speech 2. Why I am saying like this? Because we are referring that deep speech 2 and we are building our own model. Okay, this deep speech 2 will learn. Okay, and then we will test using our own voice files or our own testing data wave files or voice files. Okay, we'll get the result, and we can download that pre-trained model, or we can say the trained model, and you can apply it anywhere, like you can call it anywhere in your local system and you can use it. But here you need good GPU system for it. To train, you need to train minimum 50 to 100 epoch. Minimum 50 to 100 epoch is needed. Okay, less than that you will not get result in itself. Okay, loss will be very huge. Okay, 400 or 300 200 like that. Okay, but once if you train 50 to 100%, loss will reduce to 0.15 or 0.2, that is 15% accuracy or 20% accuracy or 10%, sorry, 10% loss or like that. The loss will be reduced to very low level and you will be getting very good results. Now let's start with the coding part. First you need to upload this IPYNB file to your Google Drive. Then open it with Colab. Okay, right click and open it with Colab. When you open it, now you need to mount it to Google Drive. That's what you are doing here. Okay, once you give permission, you need to cd to the particular folder where you pasted that IPython file or code file. Okay, you need to install first pip install Geo. What this Geo is used for? This Geo is used actually to detect the accuracy of a deep learning model. This is one of the library which is particularly used to measure, okay, or evaluate the ASR, like automatic speech recognition or like things. Okay, when we work with the speech related data, we use this Geo to calculate the accuracy and losses. So for that I am using this Geo. That you can just do pip install. Okay, pip install Geo, it will be installed. Once the Geo is installed, okay, we will go and import all the basic libraries that we need. In our case, pandas, we need pandas to create the data frame out of the data we have. Like we have voice files, we have that metadata.csv. Okay, okay, before that I will somewhat peek into the dataset in depth, what and how the dataset is structured. Here, as I mentioned, it is containing WAV files. It is containing CSV. Okay, this CSV is containing, one is file name and another one is sentence ID, audio path, or like that. Okay, so if I want all of them to be structured format, then I need to create a data frame which contains one column that wave file, wave path, and another column which contains the text, particular text it is having. So now what I will do, I will do that using pandas, and then comes numpy. Numpy is actually used to work with arrays. Anyway, in the end, whatever the data we have, we will convert them into array format itself. Okay, multidimensional array we handle with the TensorFlow. This TensorFlow is used to build the models, and Keras is also used to build the models using layers. Those layers are extracted or taken from Keras library. Then comes matplotlib. This is used to plot the graphs or images, display the images or like that. Even you can use IPython to display, and Geo, as I mentioned, it is used to measure the accuracy or loss of the models which we are working on, like voice based data. So then comes, as I mentioned, like what this LJSP dataset contains. Actually there are three different sources, okay, where you can access this dataset. One is Ketheto LJSP dataset. This is the link, you can download from here. Okay, and another one is this from Kaggle, and the another source is directly from this link, what I am doing now here. Okay, using this link, if you download that data, and you can directly access the data, you don't need to store it. Okay, you can direct download it and give it to a variable. Okay, if you download it and extract or unzip the file, a zipped file you want to unzip, it will take some time or like that stuff. Instead of doing that, using this function, you can directly take that URL and you can get the file or directly into data path variable. Once we get that, okay, once we get that, now what I see, there will be two folders. One is waves folder and another one is metadata.csv. What does this waves file contain? This waves file contain all the waves, all the voices, recorded voices. Okay, for example, we'll see one voice here.
The examination and testimony of the experts enabled the Commission to conclude that 5 shots may have been fired.
And another example.
Many animals of even complex structure which live parasitically within others are wholly devoid of an alimentary cavity. Many animals
Like this. Okay, if you want to know more about the data set, you can see here. Okay, what are the things are there, how many total clips, how many audio files are there, like 13,100 are there, total words they spoke 2,25,000, total characters used, total duration it's almost 24 hours recorded data, and these clips are very clear. Okay, minimum duration is 1 second. It means there are some voices which are nearly 1 second, and maximum clip is 10 seconds. Okay? These are this is all about the data set. Okay, you can go through it in depth. You can even visit to this Kyoto Tacotron. Okay, if you are like, we will work in future on this also, how to convert from text to voice. That will be done using this repo. Okay, Tacotron, we call it as a Tacotron is implemented by so many people, even Google people. I think they refer first time deep, there is something. Okay, Tacotron. Okay, this Tacotron is very good, which is built by Kyoto. Okay, you can use this and you can build a model which can convert from text to voice. So that will be our feature video. Okay, don't miss that. Okay, so try to subscribe like that. Okay, and we will be uploading this video even, we'll build that even. Okay. Okay, here initially I will download that and I will mention the path. Okay, where is my metadata.csv and where is my waves file. Then using pandas I'm going to read that CSV file, whatever the CSV file I have. Once I read it, okay, once I read it, I'm going to print tail or head. When I give head, I will get some top values. You can mention it here 10 or 20 or 30 or like that. Okay, if I give 10, it will give some top 10 values. Okay, where you can see, look, first column will be file name, second column name will be transcript. Okay, here okay, this is a thing. Now what we can do is, let us import it again. This contains 3 columns, but they are unnamed columns. We will name them. First one is our file name, wave file name. Second one is that main transcript, or you can say sentence. Okay, third one is normalized transcriptions. I didn't find any specialization in normal transcript, but they mention, like you can see here, okay, the data set. What they are telling about this is transcribing numbers of ordinals or monetary units expanded into full words. For example, if there is MR, okay, it is written as a Mr. or like that. Okay, these things, abbreviations are expanded in the second part. Okay, that's why we are going to use second part instead of first. So let us go with normalized, because here the sentences will be complete. So we'll go with this this as a data. So our input data is file name, our output data is normally transcript instead of transcription. Why? Because normally transcription is containing expansions. If there is MR, it says Mr. and like that, as I'm showing here. If it is gen, it takes general. It means there is a full sentence, so that will help us to get better accuracy. Now we are going to split the whole data into train and test. Here, how many rows of data we have? Actually, we have 13,000 of rows of data. Now, out of that, 90%, sorry, more than nearly 13,000 of data we have. Among that, I'm going to use 90% for training, okay, and remaining for validation. So When I get the value, I will be getting 11,790 for training and 1,310 for validation purpose. Here we imported the datasets. Here we are trying to split the dataset for training and validation. Now we need to do pre-processing. What type of pre-processing we are doing? Here we call it as a character mapping. In this mapping technique, what we are doing? Now we'll take all the possible alphabets A, B, C, D, E, F, till Z, and using a TensorFlow library called string lookup, we will give this vocabulary or character a particular array or a number, you can say. Okay, in that case what will happen is A may become a particular array, multidimensional array, say 1 0 0 0 0 0 0 0 like that, and B may become one particular array, and C will take one particular array, and D will catch up with some particular array. It means here what we are doing, we are mapping our alphabets to numbers. What is the need of mapping? Okay, whatever the deep learning you are building, whatever the machine learning you are building, they will not understand any alphabetical things. They will only understand numbers, integer, floats, or arrays. So our data should be numerical. So we are doing that stuff here. Whatever the things were there, whatever the sentences are there, we need to convert them into some array structure. Okay, to do that, first we need to convert our words into some numbers. Okay, that to do that, each alphabet should be a number, a array. So we are doing that stuff here. That's why we are using this lookup, you can see. Okay, now we will take that as an input and we will feed to this model. Okay, Cartonum. This will be having a capacity to convert whatever the vocabulary, whatever the characters A, B, C, D to Z or question mark, something like that. It will convert them into particular numbers and it will give back the result. It will be in array format. If you print, you will get an array. Okay, you can just see. Okay, I will do that here. It says keras layer. That means it is an array format and it can't able to print that result. Now we need to access both WAV files and the text information and pre-process them. How we will do it? Let us start with this part of the coding. Okay, so before that, here you can see if the given is input signal and the overlapping window. If you are good with analog signal concept, you will be knowing like what is window, what is signal. Window is another signal with particular wavelength and frequency. When we overlap that with our original signal, the original signal will be changed, like its content will be changed according to the filter that we apply, the window that we apply. Okay, but whatever the window, whatever the another second signal that we are going to apply, or that we are going to multiply with our original signal, it will be having some features. Okay, so one hop, we call it as a window length or hop size. Okay, here you can see once it goes from down to high, we call it as an hop length. Double of hop length, we call it as a window length. And whenever the two signals in the window overlaps or intersects, okay, the distance between them we call it as a overlap length. These are three information that we need before move further, because we need to predefine the window. Predefine this window signal. Here I will be using the STFT and all those stuff. That's why I'm just showing this initially. I will let you know again, once again. Okay, while I'm using that in down. Okay, all these are the features. Okay, what is a frame length? Frame length, in fact, it's a window length, which you saw above. And then what is frame step? It's a number of samples, number of sample steps. How many number of sample steps we are going to get? 1 2 3, like this. How many number of sample steps that we are going to get? That is the number. And then what is the size of FFT or Fourier transform that we are going to use? in the next part of in the continuous part of the code you'll be getting. Okay, then we are writing a function. Here we will be getting one wave file, another one is a label nothing but the text path. Okay, that's a text, not text path. Label is just a sentence of what that wave file contains. Okay, that is the label, and wave file is the dot wave files. Okay, if you feed both the wave file and the label to this function, what this will do? Okay, that we'll see. First, I will read that wave file using tf.io.read file. Okay, you can see here. Here I am using that from here. Okay, tf.io.read file. This is being used to read any type of files, not only the wave file. It can be used to read mp4 files, it can be used to read images, it can be used to read another for other format of all type of files. Okay, in my case what I am doing is I am going to read the wave files. Okay, then what is this decoding? Okay, what this decoding will do is for example, here you can see. Okay, what is the function of decoding is nothing but we will try to remove a second. I will be proper. Yeah, it will convert the data, whatever the signal data is there, it will convert it into float tensors. Okay, whatever the wave files is there, it will convert that into float values or float tensors. Got it? Then after that is converted into float, then I'm going to use a squeeze. What this squeeze gonna do? Okay, this squeeze will try to remove once or repeated tensors from or repeated or one element from the list. Here you can see. Okay, for example, if t equal to tensor is in the shape of 1 2 1 3 1 1 1, if once apply tf dot shape dot tf dot squeeze of t, it will become 2 3. It means it's try to remove the one dimensional stuffs. Okay, it will try to keep only multidimensional spaces in the data. Otherwise you can directly mention like which location of ones can be removed. Okay, here I am mentioning 2 and 4 0 1 2, it means it will be removed. 3 4 it will be removed, and other things will be as kept as it is. It means here directly we are doing only this stuff, we are not mentioning which one to be removed. So in that case what it will do is it will first see the dimensions. If there is any one dimension one in the dimension, it will just remove that stuff. That's all it will do. And okay, here why we need to do is that one data will not carry that much information here. Okay, we try to remove that. That is the thing. We are trying to reduce the data without losing the main information. We are doing like by doing this we will reduce the data, we will reduce the processing time, we will reduce the storage, data will be reduced, but it will also increase the accuracy of our models that we are going to build next. Okay, then what we are doing, we are casting it. Okay, the audio file, whatever the audio file will get out of it, we'll cast it. Here you can see what the casting will do. Okay, it will convert into another data type whichever you are mentioning. If initial my data type is 1.8 2.2, if I mention okay cast it to tf.float.32, it will convert that into this data type, particular data type that you are going to mention here. In my case I am mentioning like convert it into tensorflow dot float 32. It means float 32 type of uh, data will be there. Now like initially whatever the float will be maybe 32 64 like that, but now it will be casted to only 32. And after that whatever the signal comes out of this pre-processing stuff, whatever we did now, that I'm going to feed it to STFT. What is this STFT? Short time frequency. Okay, one second. Short time Fourier transform. What is Fourier transform actually is? Okay, here I'm going to give you the equation. Okay, this is the equation. In Fourier transform what will happen is we'll be having one signal. Let me explain with a diagram, then you will understand what we are doing actually, what is the main aim behind this STFT. Okay. So let us say this is my signal. I am having this signal. Now this will be a very big signal, but I will be having a window. Window is nothing but another type of small short signal. Okay, okay, this is another signal. So this I say S1, this is W1. Okay, this is also S of t. It means this signal is depending upon time, and W is also depending upon time. Now what I will do is I will apply this signal here with the same size. Okay, maybe this comes here first. Okay, first time I will multiply both of the signal, and initially I will divide this original signal into multiple signals, okay, which are in the same size of the filter or the another signal. Okay, so this will be splitted multiple times. Okay, now I will apply this filter on all of them. Okay, that is short time Fourier transform. I will apply the Fourier transform against the shortest time. It means a small time of the whole signal, because this x-axis will be time. If you know about the signals, x-axis will be time, y-axis will be amplitude. So after doing this, we will change this signal. Okay, the signal will be changed to some other format where their wavelength will be multiplied. Okay, their wavelength will be multiplied like x. If the wavelength of this is x, if this is y, it will become xy. No, x plus y are like that. Okay, there are some equations based on that it will go. Now the original equation is like this. We'll multiply x of t with the w of t with a change in time. That means we are going to shift that window. T will always keep on changing. Okay, once we do that, okay, this Wikipedia actually explains very well the mathematical behind the whatever the stuff I'm telling you, like. Okay. And one of the window function I can mention is Hamming window, Gaussian window, Hamming window. There are some windows. Okay, windows nothing but there are some predefined small signals or filters which we apply on our wave signals, which convert them into a particular shape. Then once we're done with that, okay, whatever the thing we will get, we will apply tf dot absolute. What this absolute will do, what is our signals will look like? Our signals, okay, let us say our signals will always be in the format of a plus bj format. Okay, what is the absolute value? A square plus b square under root, I think. Okay, so once we apply magnitude, we will get only magnitude from the equation. This is signal equation. Signal equation will always be complex. That is a plus bj. If it is 2 plus 3j, like that. Okay, we will define like this. Okay, signals will be in the format complex. From complex values we are going to get its amplitude or magnitude, we say. Okay, magnitude will be square of amplitude or like that. There is equation for that. Okay, if you want further information, I will let you know that. Once we done that, we'll do power. What this power will do? Okay, actually tensorflow dot power. No, if I use tensorflow dot power, tensorflow dot power of x comma y, this means it is x power y. If my x is 3, my y is 2, then it is 3 power 2, that is 3 square, it will be 9. In my case I'm just saying, okay, x comma 0 point or wave signal comma 0.5. It means on each element in that tensor, on each element it will be power to 0.5. It means all the elements are now divided by 2. Okay, because x power 1 by 2, it will become like this. Okay, it will be applied to all the pixels, or in this case not pixels, in this case all the signal waves. Okay, signal element will be now done powering. Okay, once the powering is done, then we are going to apply mean, reduce mean, like everything will be divided by the maximum value. Okay, tf dot reduce mean. Then reduce standard, we'll do reduce standard over it. Okay, if you want more you can visit to the sites, okay, official sites. We'll check that. Okay, you can visit to their website, TensorFlow website, to get much more information about it. Okay, what does this will do? Okay, now you can see here. Okay, if my values are 111 and 222, reduce mean. Okay, if I apply like that, the x-axis will be reduced on that particular element. You can see. Okay, yeah, reduce input tensor along the dimension given axis by computing the mean of element across the dimension. It means if I say it will find the mean, it's just like normalization, divide by the uh, whole number, how many number of there, divide the element by that, and it will reduce the scale. That's all. Scale reduction will happen by using the mean value, reduce mean value. Okay, then once we are done with that, we will finally mention, like, we'll try to say what is our spectrogram. We need to define that spectrogram. Our spectrogram will be original spectrogram, whatever the pre-processing we done till powering. We take that minus what is the mean value was there, and what is the standard deviation, plus one that's e power minus 10. Okay, then we'll get the spectrogram of our signal. Okay, now then spectrogram is our input actually. Now spectrogram can be processed and it can be converted into some array format or like that. We'll see how we are going to do that. Then initially we had so many labels like texts of all the wave files, that we will reduce to lowercase. We will encode it, and then we will apply char to num, which we defined above. Once we apply this, all the text will now be a numerical information. Okay, this is a function where we are going to use that. Below you can see. Okay, here for training data set I will call train df why I mentioned. Okay, well, while I am splitting, I splitted data, some for training and some for testing. Now the training data frame file name, that means only the file name dot wave files I will take, and the second part one is normal transcription. Okay, I will take these two, and then what I will do is I will apply encode single samples to my train data set. Whatever train data set was there, I will push to encode a single sample. Okay, now this will be applied over it. It means this function will be applied to all the wave files which comes under train df. Okay, the same and also the labels. Okay, both of them it will apply to both the things. Okay, and it will be batched. I initially mentioned. Okay, batching nothing but, for example, when you go to any fruit shop or any supermarket, if you pick any object, it will be with its tag. It means the tag and the object is batched, then only you will understand what that means. Here also, whatever the wave signals, pre-processed wave signal is there, or in our case the result will be spectrogram. That spectrogram and pre-processed label, both of them will be batched now. Okay, once that is batched, okay, that is our main data. Like same thing I will apply, same batching I will do it on my validation dataset, and I will name it as a validation dataset. And then I will visualize, I will try to print. Okay, we can print out a spectrogram. Okay, I am printing the spectrogram and also the signal, wave signal. Okay, you can play it. Okay,
And so developed.
then I need to build a model. Here we need to understand about CTC laws, what this CTC and why this CTC is used. Okay, for that I will refer you one of the finest and one of the most visited page. Okay, where he try to explain it very better. Okay, we say like a connectionist temporal classification. What does this will do? Okay, initially This is a convolution neural network which is used to get the loss. You may be heard of RMSC loss or like that. You heard of some named losses. The same case, this is actually used. Whatever the CTC we are saying, this is normally used in the condition of RNNs that we are using for our model. Okay, when it comes to RNNs, we go with a CTC. Why this will do? What is the importance of this? Is, for example, I'll draw and I'll try to teach you. Okay. Okay. For example, this is my sentence. Okay. Say, I am very good. Very good. Okay. Like this, there is some sentence. Now, in the case of from image to text detection, in that case, okay, in our case, there is a signal. There will be so much of space, and also there will be a signal. Now I can give my deep learning model the entire signal as an input and its sentence as an output and I can train that model. But the problem is here data will be very huge and it will take all the empty spaces also as an input in the case all the information. But when it comes to CTC, it is been structured in such a way it will do checking. Okay, it will check with ground truth and the input you are feeding to try to check and understand where the data hides. It will try to concentrate on that part. Okay, it will try to concentrate on only the data available part. The same thing you can use it in text recognition also. It will try to recognize only that area. It means this actually used to get the concentrated area. It will do try and error like stuff. It means it will apply multiple times a filter over a data and it will try to check where the data is available. There only it will try to check take that as an input. Instead of taking the whole data, it will increase the accuracy of our data and it will reduce the loss. Even CTC can be used as a loss function. Okay, it means it is used to measure the loss of the model, deep learning model. Okay, and as I mentioned, this explains it very well. Okay, Harald Skilled. Okay, Skilled. He wrote it very well. Okay, you can go through it and you will understand it very easily. Okay, why we need to use it and what is the stuff, what is the importance of CTC that we are defining here. Okay, finally it will give us the loss, and here we need to understand where we are going to use this. Okay, that I will let you know. Now we are going to build a deep learning model which is similar to deep space 2. That's what we are doing here. Okay, we are going to build a stack of deep learning layers. Now initially I will take the input. Okay, once I will take the input, what I will do, I will reshape it and then I will give it to a stack of convolution layers, convolution layer 1, convolution layer 2, and after that reshape it again, resulted data, and then this is our main area. We are going to define our RNN layers. Once we are done with the RNN layer, we say the dense layer. Why we need dense layer is we need to define what should be my result. Okay, that will define here. Okay, it should be X. Only one data we should get the result. Okay, and we are trying to get like what optimizer I should use. It means we are doing compilation also here. Complete model will be get as a output. Once we done that, I will call this function here, build model. Here what I will do, what's the input dimension, FFT length 2 plus 1. FFT length we already defined above. Okay, that should be given as an input, and then output dimension. Okay, once we feed that, to our model will now be completely created with all the parameters. Okay, now we are going to train it. Okay, now for that callback function is there. Okay, if you want to use callback function, it's fine. If you don't want to use, also fine. Callback function is not must and should case. Okay, Here you can mention epochs. Epoch should be minimum 50 to 100. Okay, it's if it's less than that, then you are not going to get any good results. So then, as I mentioned you can callback, you can use callback, or otherwise it's fine. Okay, you can use only train data set. Validation data, you can use validation data set. Okay, callback if you want to use, you can use, otherwise it's fine. Okay, epochs, if you need to, you need to mention epochs, how many number of epochs you need to train the model. Once you are done that, once the running is completed, you can predict it on some test data. Okay, here you can see on, I'm going to predict it on X. Okay, what is this X? X is actually the part of validation data set. Okay, here I'm going to get some info, some data from validation. One, I am getting one signal from the validation and I'm going to apply it here. So once if you train it for 50 to 100 epochs, you are going to get results like this. Okay, as I shown before, you are going to get good results. Okay, no problem at all. This was the whole concept. Okay, if you face any problem anyway here, you'll let me know. And the one thing I forgot, okay, you can just message us or contact us, the number I gave below. It's fine. And you need to use a good GPU. Okay, then only you can run it around 50 to 100 epoch. Even you can't run it on Google Colab. You can try it in Kaggle. Okay, but there it will take lot of time. Okay, a lot of time it will take. Better to buy the server in AWS or Google Cloud and you can try it out, then you will get the results. Yeah, this was the thing. Okay, if you like the video, subscribe and click on like button, and it will be very helpful for us, and it will be a supportive thing for us to make some other videos which will be very helpful for you. Okay, thank you very much. We'll see you in next video.